so thankful. Oh, just shout out to the organizers and the attendees here today. It's not easy to run a conference, and it's not easy to run a conference with with a legacy like PyTexas has. And so just really a round of applause for the organizers. Thanks so much. So just to set the stage for what we're going to be talking about today, I am bringing up some deeply technical topics, research and emergent technologies in AI, and I am making parallels with your career. The goal of which is for everyone to walk away feeling like they have some agency in how they approach machine learning and AI, as well as agency in your career, right? And so I'm making some of the parallels. Another through line, maybe more of a caveat, is that when you are comparing a human system to an artificial system or a complex technology system, it is easy to forget that humans have needs. We need water, we need love and support, we need to get up and walk around and step away from our computer. So as I talk about optimizing, I want to optimize for things that make healthy humans, right, and healthy careers. So just want to give that caveat as well, because I think a human-centered approach is really important, but then I'll also be talking about kind of optimization and fine-tuning. Okay, so hello, my name's Dawn Wages. It is an honor to speak with you all today. And models have been a growing part of the global zeitgeist for the last several years. And at the same time, I get questions from people as I travel, I'm in developer relations, expressing concerns over the tech job market and how to make the most of that career. There's a lot of advice that I give. Usually it starts with learning their passions, understanding their interests, optimizing for outcomes, and then understanding the sense of urgency in changing their career. But the second phase of that conversation, which is much more long-term, is understanding their specialization, their domain expertise, and how they can get deeper into that stack so they can be invaluable in their next chapter. Today, we'll combine both of those conversations together. Again, I mentioned that there's a lot of sources in this conversation, and so if you're interested in the research and some of the articles that were behind this presentation, the QR code will take you to a landing page for it. There will also be the link at the bottom for it. In general, my presentation style is to speak to slides, but not regurgitate the language on the slides. Sometimes that adds accessibility layer. So if you would like to have the language on the slide to look at, I will not blame you for looking at your phone as you are reviewing the slides. And I have she, her pronouns. I go by Dawn Gibson Wages. The community has seen me get married, so I added an extra name in the middle. I am in developer relations. I'd like to give a thank you to Anaconda, who paid for me to be here today. It's my employer, and I lead the developer relations team. Oh. Thanks. I also co-host the Sad Python Girls podcast for those Sad Python Girls Club podcast. It's been around for a couple of years with my old teammate from Microsoft, Luciana Abud, and we've been on hiatus and we're coming back this summer. So add it on all the places you do your podcast listening. I'm also a local first AI and ML enthusiast. It is not something I'll talk about here, but as I continue to grow in my AI and ML journey, I really have optimized for processes that can run on device, because that is one of the things that makes me feel like I have the agency and ethical implication and understand the ethical implications of my AI and ML. So if you want to talk about in the hallway track, local first AI and ML development, please let me know. There is also a through line with my employer, but we can wear multiple hats, as Mason has shown us before. So many of these abstracted analysis of specializations that I'll discuss will derive from economic definitions. That is a foundational concept. We'll also get into some philosophical definitions, like when I talk about ontology. In general, the concept can be at odds with being agile by being very specific. And what you gain in your competitive advantage, sometimes you will lose in the resiliency, in your ability to pivot. So as you're specializing in models and specializing in your career, you're doing a cost-benefit analysis of sorts every step you take as you dive deeper into expertise. Click, 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 click. Okay. The order of events today, we're going to start with understanding specialization in models and in your career, and then we'll apply 3 kind of general topics that are sum up to recommendations. Efficiency through expertise, smaller iterations, and hopefully big wins, and then having the sovereignty over your stack. But this is an experimentation loop. It should look very familiar if you are a software engineer, but this could also just be a mental model of the way that you are experimenting every day, or if you're a researcher or a scientist. You're planning, you're designing, you're building, you have test cycles, and then you have a release flow. But here's my experimentation loop. It's not as beautiful. There's some false starts, there's some planning, and then some more planning, turning it on its head. I'll do some test cycles, but maybe there's more intuitive testing and or explicit testing. And that release cycle is in order to not necessarily deliver a finished product all the time, but also to share my work and continue conversations. But as we're specializing in these experimentation loops, the necessary activity before you can get into your specialization, it unlocks several key benefits. And it increases the economic or personal efficiency. And there you find that you can have some interoperability layers between yourself and other systems that are also specialized. But a caveat here, as I mentioned, in-progress research that's not quite published yet, UC Berkeley has an informal academic paper with early findings that AI is not actually reducing our work. There's this utopian idea that if we can all get AI to automate all of the boring stuff, shout out to Al as he's teaching us to automate boring stuff, that we will somehow have all of the time free to do all of the fun things and stay away from our desks and talk to our rubber ducks and indulge in some of those thoughtful endeavors. But that's not true. AI, at early research, is actually just intensifying our work. AI makes it easy to start and stop continued tasks, and it's seeping into our breaks and our natural pauses. So just a caveat to remind everyone to drink water and step away from your desks. 3 approaches to specialization, as I mentioned: efficiency, iteration, and understanding your resources, so that sovereignty of your stack. In order to give more thought processes or more details on model optimization, and specifically language model optimization, I want to talk through what it means, the full process of covering LLMs in very, very high level. And just so you know that this is setting the foundation so I can bring some parallels to your career later. So LLMs learn from more focused inputs, and in each stage of that training process, starts on the far left with pre-training. You can be trained in a mix of unlabeled and proprietary data without any human supervision. And then that second phase is fine-tuning in the middle, where narrow data sets and human feedbacks are introduced as inputs into your base model. And fine-tuned models can then enter as an additional phase when humans with specialized knowledge are implementing those models with prompting techniques, and that can also transform that LLM into more specialized tasks. So we're already getting into understanding expertise and specialization. You're feeding that data, and it learns patterns and internal parameters. This is also called your weights. And to minimize prediction errors like your loss functions, you're using an optimizer, and you're iteratively improving that performance, all while turning your settings and to prevent some of the overfitting, and that it generalizes well to some of the unseen data. So what we're building in Lay is we are building a complex system that is taking inputs, learning or creating connections from those inputs, and having continuous growth in those inputs so we can use that new model, that new algorithm, and apply it to unseen data so we can have that do the thinking for us because we put in all of this additional work. I want to mention that scaling laws will apply even in some small language models. That's where performance will improve predictably with size, data, and compute. And then with small language models or things like that, small models will max out faster, and they will have plateaus that come sooner. So balance is critical, and you need to match your data set with your model capacity. And then the last part is inference or runtime. So when you are first starting or hitting go or going to the command line to initiate that activity, that is inference. Inference at runtime. You are either doing it locally or you're doing it on some remote compute, and you are accessing that model to be able to do the thing. So here, I want to talk a little bit more about ontology and domain expertise, because this is important in building the boundary of what that expertise is. Ontology has deep roots. Shout out to my colleague Dana, as we were having some awesome conversations about it yesterday, in philosophy, as well as information architecture. And so ontology creates those well-defined boundaries, and then thus, applying it to our career, we are now able to create in our mental models domains, and in real models domains. Both us and our models succeed not because we know everything, but because we operate within a well-defined ontology, whether we know that or not. So here are some examples of ways to apply in technology on the top and in your career domain or ontological techniques. OWL, RDF, and SparkQL are very well-known, established frameworks that ontologists, expert ontologists who are deep in this domain, currently use to apply structure to nodes and relationships as they get deeper, and then applying each of these established techniques to the corpus or the context of your model will continue to create some of that semantic awareness. Semantics, just to kind of disambiguate the difference between semantics and ontology, you may find some semantics more in this space, but ontology is a growing language and discipline as it interjects to AI and machine learning. Semantics is creating the points from the same words and understanding the context that it lives in. So if I say sidecar, I could be saying sidecar at a bar. That might be what I'm ordering. I could say sidecar at a motorcycle dealership, and that is what I want to add to my motorcycle. Or I can say sidecar to my Azure application, and that means that I may be adding an additional application to my monolith or something like that. All the same word, but semantics means that they have relationships with each other and relationships in the context that you're using it. Ontology, differently so, is drawing a boundary around all of the different data points that you are collecting and creating this domain or expertise of of the subject. So you can have a domain for motorcycles, for drink menus, and for deploying your Azure service, for example. I went a little bit deeper into OWL. OWL is the ontology web language, and RDF is resource description framework. There's also a process called triple stories, which is bringing together 3 relationships for any node or foundations of ontology. And I just want to bring that, so if you're going to be looking it up later and you want to try applying that as a layer for your machine learning and AI, these are some of the things that you can dive deeper into. And there's a shift from passive models to autonomous agents, where ontologies are now acting as critical boundaries for enforcing some of these logical constraints. And this ensures that the semantic reasoning, the semantics that we were talking about before, across multi-agents. So let's step back and talk a little bit about agents. Can I get a raise of hands? Who's familiar with, first let's start out with models, AI models, just general models. All right, okay, cool. I did just jump in. I probably should have asked that question first. What about language models? Okay. And then what about agents? All right. So the zeitgeist is in the room. Okay. So multi-agent fleets, specifically if you have single function agents or you're using agents all together in Congress, there is lots of research on what is the most efficient approach. So sometimes there's like a waterfall approach, or are they all running in parallel and communicating with each other? Sometimes there's a parent agent and children agents. But each of those approaches are working on what is that domain and expertise in order to optimize for efficiency. And then here's the stack. So this is more closely related to a software stack, but it is applied to an intelligent application. At the lowest level is your infrastructure. So if you're running on GPU or particular hardware, then your runtime, that would be your operating system, your packages, your package manager. Above, you have your frameworks. And then your applications and your workflows. So what other external applications and endpoints are you interfacing with? And then at the top is your system output. So that could be some generative text or images or something like that. And then sometimes or an error log. And sometimes there is this concept in harness engineering where you're taking that output and you're feeding it back into your system as additional context to make it smarter and hopefully more domain specific. There is a theme. And my journey has led me here. So I did have that intro slide on who I am, but I have been in the Python ecosystem for about a decade. A lot of that started in web development. I had a short foray as a citizen data scientist back in 2015 when I saw the hot craze. But then I fell in love with the community and with web development in Django, and I was more on the framework and application layer. And then I moved into my job at Microsoft as TPM, working with developer relations and VS Code. And my love for the Python team at VS Code that puts deep expertise in optimizing that environment layer and making it easy to run Python in your environments is just immeasurable. I love that team. But I learned a lot, and I learned a lot about how Python can be a headache when you're just getting started, and then how the ecosystem has evolved to support it. And now, as I work at Anaconda, we have Conda the package manager, and we are known for working really well on multiple architectures. So people are maybe interacting with that kind of consideration as they are using, for example, Docker. Docker is very popular. I love Docker as well. But Docker creates a container where you can obfuscate or remove the consideration of your architecture layer, while Conda and some of those considerations will solve for architectures. So we maintain large, wide, and deep matrices on Python support matrices on our packages to solve for the architecture layer. And so as we are pursuing ontology, general intelligence is really good for exploration and remaining flexible. But specialization is good for reducing waste, optimizing resource allocation, identifying opportunities for improvement, and perhaps creating a competitive advantage. As we add you as a layer with ontology, that and your career, general intelligence is good as a first line of defense roles. For example, triaging small teams or solo entrepreneurship or management. And specialization is good for creating that deep and technically sound impact. And here is where I really want to underscore some agency that you have in this, right? We are treating you like you are this closed source system that is just here to be fine-tuned, all of the knobs and levers. But here is an opportunity that you can strategically choose what you do not know. Specialization is the art of strategic ignorance. So let's add some specialization techniques to the models. To our models. We went through that full process of what the model lifecycle looks like as a primer. We'll not be doing that for your career, but we will have a full process on that. And we can also bucket them, as I bucket a few, in those three categories that I mentioned: efficiency, iterations, and resource management. These are only some, not all of them. For example, low-ranking adapters, instead of adapting billions of parameters, you add LoRa adapters on small trainable models inside those transformer layers. This is during fine-tuning, but is not fine-tuning exactly. But it makes specialization efficient and less compute and less memory and faster training. Conversely, fine-tuning is retraining all of the parameters on a particular data set. It's the most compute intensive, but gives the deepest specialization. And it changes where that compute intensivity shows up, whether it's at your inference layer at the very end when you are accessing the model and building your intelligent application, or if it's earlier while you are doing your training. For example, you can train a small model entirely on legal contracts to make a contract analysis bot. Parameter efficiency specifically is one that's instead of running complex ML models to identify every instance, you have a reasoner model that can automatically classify data based on pre-trained rules. To add an ontological layer on top of this, you can have ontology-driven data cleaning as an option, or there's new world models that are really kind of cool. Their approach is to have this generalized intelligence as a bridge to simulate a real-life gap. So instead of trying to predict the next word, which is what language models do, and it is each next word is based off the previous words, and it is the most logical next word, instead it tries to predict the next state of your environment. That is more efficient in the sense of learning in the data usage, but they are also very computationally demanding. RAG is an architecture pattern. There's RAG, there's chain of thought, there's many more that are coming up, but this is a different part of the stage where as you are, during your inference, you are, for example, using a prompt where you are summarizing the latest medical guidelines. You will have a retrieval model that searches an external database as an additional point, and then it will add the relevant passages back into your context. And I want to do a shout out for Agent OM. I've not played with it, but I came across it in my research, and it's been really exciting to kind of see how it works. But it's a large pre-trained foundational model that are when you have large pre-trained foundational models that are impossible to retrain or hard to fine-tune, you can use approaches like Agent OM. It's an open source tool, and there's also some research papers on it that will help you with using the model of it itself, or chain of thought, or RAG, or ICL, in prompt engineering techniques. The last but not least, I have a couple more, but the SLMs are small language models and affect the entire life cycle. Knowledge distillation, pruning, quantization, and focused training data are all part of this approach. And so when we follow that techniques, you can apply it to your career. So I just want to kind of give everyone a breathing room. Like, we went through some really deeply technical concepts, right? And it's just a smattering, and it's in less than 10 minutes. We're going to take a different, change gears and start applying these 3 categories to your career, and maybe you'll see some parallels in language and approaches between them. Efficiency, iteration, and resources. Just like your specialization techniques for your models, we have these 3 categories that I think are really fun to dive into. So the Pareto principle. Who's familiar with the Pareto principle? Okay, a couple hands, that's great. So instead of trying to learn everything, identify 20% of the skills that drive 80% of your results. Again, an agency-giving kind of technique to be able to focus in on where your time is going and what is important. For example, a senior software engineer may focus on system design instead of leadership and leadership rather than learning every new framework. And that's also something advice I actually give to new developers who are worried that their job is going to be replaced by AI. And honestly, that's a really apt and relevant fear because the market is shifting to support that. You're finding less and less junior engineer job postings these days. So if you are a hiring manager or have been the ear of any hiring managers, please encourage them to start hiring junior engineers again and adapting their engineering approaches that support the new way developers build. They do not need to always go through leak code interviews when you are encouraging them and or penalizing them for not accessing or using intelligent chat for their code generation. But this efficiency that provides, you are able to adapt quickly without burning energy on low-value tasks. Knowledge base or knowledge retrievals, I mentioned RAG. This is like RAG for your career. When I start programming, I always keep a wiki section open, especially if I'm contributing to something low level and open source, and it's for me to reference later. My rote memory is like a sieve. I will not remember anything at all if it's not written down. So giving yourself the opportunity to do your own personal RAG approach, to have a corpus of your own knowledge. You can have, it can streamline your mastery in your templates, your frameworks, and your playbooks. Distillation. I do this all the time in developer relations. So I teach to learn. Many times I will set myself up for an engagement where I know I will need to teach something multiple times over, and just the praxis of teaching it multiple times over, getting those questions, means that I am deepening my expertise in that domain. It reinforces mastery while I get to scale my impact, which is really nice. Pruning, similar to the Pareto principle, cut that low-value work. It's also important, again, to hiring managers and people who manage teams. It's important that you set the expectations on what is valuable to your team members so they can optimize for the same thing. It's important that we're all pulling in the same direction. And the last, I think, second to last is domain flexibility. Small modules of knowledge for adjacent domains as you need to adapt for flexibility. This is similar to maybe multi-agent models or having a RAG approach where you are reaching out and just getting more information and bringing it back in. But this is in small scale. So, for example, if you want to get a certification or have a friend who's an expert or be in cross-functional collaboration groups or things like that. And the last one, scaling laws. So this is more approaching like balanced growth. More effort doesn't always equal more results. So balance skills, you can balance the size. This is like skills, your data, this would be your experience parallel, and your compute, which is the parallel to your energy or your time. And it will help in your efficiency, hopefully, when applied, please give me the feedback if it's not working. Hopefully, it reduces your burnout while maximizing returns. And when I've given kind of feedback to friends and to myself on how to avoid burnout, what I want to tell people to do is just relax, put down your keyboard, turn off your monitor, and kind of step away. But it also remains kind of ignorant of the fact that we are in a capitalist system and high pressure environments, and giving that advice to a junior engineer, although it is well-intentioned and really kind, I don't want to leave anyone I care about in the lurch, not realizing or pretending like we're not in a competitive landscape. So figure out where to balance, and also find a cadre of friends to help you. So that is the crux of the presentation. The last little bit is just summarizing those last three considerations again, putting them back into context, and then we'll say a quick goodbye. So the first, efficiency through expertise. Similarity clustering is another approach, so I didn't dive into too much, but if you are clustering heterogeneous activities, you can increase efficiency. For example, clustering of companies, economies, or resources, and that line, that U-shaped curve that you see is optimizing that output, and eventually you will see a decrease on your investment return, right? So it is one to trying to maximize and get to that top of that curve, and recognizing when the additional effort or input reduces the output. Small iterations, big wins. Set yourself up for workflows that allow for you to check in frequently. Incremental progress compounds to large achievements over time, and create those check-in opportunities. And last but not least, you get to have sovereignty over your stack. Take agency in your workflow, in your software, or in your career. So we have workflow data model infrastructure on your software side. You can have your career maybe similarly, but not one-to-one. Your income, your reputation, your network, and your skills. This is the stack that you own. And just to do like a quick through line or kind of a plug for local first AI and ML, it is my navigation of this new AI landscape. I was originally really reticent. I still am a bit AI reticent in the ecosystem. And so for me to understand what owning your stack is, which is local first in my context, I feel like I have sovereignty over my data, over my compute, and the ways that I'm able to let my agents run. This is also kind of the reason why a lot of people have been going out and like buying all of those Mac Minis off the shelf. You don't need a Mac Mini. You don't need a Mac Mini. Let me de-influence all of you. But you can show up and have boundaries and containments and start experimenting in small loops, enable to own your stack. And all of this together, hopefully in this thought experiment, please, please, please reach out to me if you are experimenting with this or you find that there's holes in some of this analysis that I have. I love these debates and I really appreciate them and I think it makes us all smarter. But hopefully in this exercise, it creates sustainable autonomy and allows for deliberate refinement of your model and your career. Thanks so much, everyone.